Hello out there, welcome to this tutorial on transformations. In this video, we'll be looking at translations. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on transformations. First, we look at definition. Translation is moving an object from one position to another, horizontally and or vertically. While translating an object, each of the vertices must move exactly in the same way. The translation vector must be specified. It gives both the horizontal and vertical distances moved. Given the translation vector xy, where x is representing the horizontal movement and y represents the vertical movement. If x is positive, the movement is to the right, and if x is negative, the movement is to the left. Also, if y is positive, the movement is upward, and if y is negative, the movement is downward. So given the translation vector xy, x represents the horizontal movement, while y represents the vertical movement, as explained. Then demonstration using this rectangle. So we look at this. This is the horizontal movement, while this is the vertical movement. We can also move the object to the left and then down. It can also be to the left up or to the right down. So whichever case. Now we solve some problems. Problem 1. In the diagram, translate the object by each of the vectors A 5, 4, B -2, -4. Remember, this is the x component and this is the y component. The x component, the y component, the horizontal distance and the vertical distance to be moved. Then we translate the object. For your information, we just need to pick one of the vertices of the rectangle and move it 5 units to the right because it is positive, and then 4 units upward because it is also positive. So we are picking this vertex. We move it 1, 2, 3, 4, 5. So we have achieved the horizontal movement. Then we go vertical and we are going upward. 1, 2, 3, 4. Which means the vertex, when translated, is coming here. So we don't need to go and be moving the other vertices. We can just use this point to draw the rectangle, because if we move this now, 1, 2, 3, 4, 5, 1, 2, 3, 4, it will be coming here. So we just mark it out. We can use these 2 points now to get our image, since this is 1, 2, 3. So we come here, 1, 2, 3. So the next vertex will be here, and 1, 2, 3, 4. So we now join the 4 points to get our image. So we join here and there. So that is our image. From here demonstrated, this image moves 1, 2, 3, 4, 5. Then it moves upward 4 units. 1, 2, 3, 4. So you can see that, and that is for a part of the problem. And we can have the vertices to be here is going to be 2, 2. This is 6, 2. Here is 6, 5, and the last one is 2, 5. And that's all for problem 1A. Then we go to 1B. For 1B, since the x component is negative, which means the horizontal movement is going to be to the left 2 units. So if we are taking this vertex here, we move it. This is 1, 2. We've gotten that. And since this is the vertical distance to be moved, it is negative. We are going down by 4 units. We go 1, 2, 3, 4. We have this vertex moving to this after translation, and we can now count 4 units to the right. 1, 2, 3, 4. The other vertex with this one will be here, and 1, 2, 3. This vertex will be here, and 1, 2, 3, 4. 1, 2, 3, 4. The other vertex will be moved to this place. Then we can join to have our image after translation by the vector -2, -4. We also demonstrate the movement. It moves to the back 1, 2. It stops there, then down 4 units. So we are going to have 1, 2, 3, 4. We have that image there which represents the translation in B, and we can then go ahead to state the vertices. So we take this vertex here, which is -5, -6. So we have -5, -6. This vertex is going to be -1, -6. We have -1, -6. Here is -1, -3. And the last vertex is going to be -5, -3. So with this, we are done with problem 1. We then go to problem 2. For problem 2, translate the object on the grid by the vector 7, -2. Give the equation of the line of symmetry of the image formed after the translation. For your information, this is the horizontal component movement by 7 units. The vertical is -2 units. I told you positive means to the right if it is horizontal movement. Negative means downward if it is vertical movement. We pick one of the vertices again and move. Then we get the other points to form our image. So we are picking this vertex. So we move 7 units to the right since it is positive. So we have 1, 2, 3, 4, 5, 6, 7. So that is the horizontal movement. Then the vertical movement, we said it's going to be down since it is -2. So we move 2 steps down. So this point now will be moved to this point after translation by the vector. So we can now use this point now to get the other points. For your information, if we are to move this 1, 2, 3, 4, 5, 6, 7, 1, 2, so it will be here. So we can now draw the line up to this point. We have it there, 2 down, and here is going to be 2 units down, then 1 unit inward. So I have 1 unit inward here, 1 unit inward. From here now we count 1, 2, 3, 4. So we also count 1, 2, 3, 4, and then complete our image. This is the image after translation by 7, -2. Then if we wish to demonstrate it, you look at it, it moves 1, 2, 3, 4, 5, 6, 7, then down by 2 units, 2, and that is all. So this is the object and this is the image. So we go further to give the equation of the line of symmetry of the image formed after the translation. So from here, this is letter T, and letter T has only one line of symmetry. That is the line that divides the shape into two congruent shapes or two equal halves. So we have that line here. If you look at it, this is the line, and the equation of the line of symmetry now is x equal to 3. If you see, this is the line x equal to 3. So we have it as x equal to 3. And that's all for the solution of problem 2. We then go to problem 3. For problem 3, describe fully the single transformation that maps A onto B, E onto C, B onto C, and C onto D. Starting from A onto B, the transformation is translation. Then we now get the translation vector. So to get the translation vector, we pick one of the vertices. We are picking this. And when we pick this now, it is in line with this. This vertex corresponds to this vertex. We count from this line until we get to the line of that same part of the image. So we count 1, 2, 3, 4, 5, 6, 7. So the horizontal movement is 7. So we are here. We then move up 1, 2. You can see now the horizontal movement is 7 and the vertical movement is 2. Both positive. This is to the right and this is upward. So the translation vector now will be 7, 2, and that's all for A. Then we go for B. So again, this is translation. It is translation since it moves to the right then down. Then we go ahead to get our translation vector by choosing one of the vertices. I choose this vertex here. I'm going to move 1, 2. When I get here, I go down to get to this point. So I move to the right again, 1, 2. Then I count down 1, 2, 3, 4, 5. So this is it now. Remember, the horizontal component is 2 steps. So we have the 2 here. Since it is to the right, it is positive. And the vertical distance is downward by 5 units. And since it is downward, it's going to be -5. And that is the translation vector for the transformation from E onto C. Then we go to C part of the problem. For C, B onto C. Again, it is translation. It comes down then back. So since it is coming down, remember it's going to be negative. And since it is going to the left, it is also going to be negative. So we move horizontally first. And then to get our translation vector, we are picking one of the vertices of B. If we are going to move, we are going to move just a unit backward to be able to come straight to this point again. So we move a unit to the left, 1, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 units downward. And that is the point there. So meaning this point when translated will be here. So you can see now that the x component is -1 since we moved only 1 step to the left, and since it is to the left, it is negative, and we moved 9 units downward, And since it is downward, it is also going to be negative. So that's all for problem 3C. We then go to 3D. C on to D. Again, it is a translation because it moves up, then back. And for the translation vector, we pick one of the vertices from object C. So if you look at this now, this vertex is corresponding to this vertex. Since we are to move horizontally first, which means when we move and get to this place, we then go upward. So how many units? 1, 2, 3, 4, 5, 6, 7, 8. So we now go upward, 1, 2. So this is negative because it is moving to the left by 8 units, and this is positive 2. So the x component now is going to be negative 8. You remember 1, 2, 3, 4, 5, 6, 7, 8. Then upward, positive 2. And that is the translation vector that transforms C onto D by translation. So with this, we are done with problem 3. We then go to problem 4. For problem 4a, translate the triangle on the grid by the vector 4, negative 4. B, give the coordinates of the point M after translation. C, translate the point M by the vector negative 3, 5. So if you can see this now, a point can also be translated. That is why we are trying to bring it into view in this problem 4. So now we go ahead. It is clear now we are starting from the point M for our translation. So we count 1, 2, 3, 4. The horizontal movement is 4 units to the right and also 4 units downward since it is negative 4. So we have 1, 2, 3, 4. So we have this point M moving to this point after translation by the translation vector for negative 4. We can now use this again. We move 4 units to the right, 1, 2, 3, 4, and 4 units downward. It is downward, remember, because it is negative 4. So we have 1, 2, 3, 4. This vertex here will be translated to this. We join it to our original point. Then here we have 1, 2, 3, 4. Then 4 downward, 1, 2, 3, 4. So it is at the origin. So we then join the point to have our triangle as the image, where this is still the object and this is the image. And that is for the A part of the problem. For B, give the coordinates of the point M after translation. So on our image, we have used this point M as our point of reference for the translation, and we saw it here. So we are going to name that point as M prime. So that is the image of point M after translation. So on the x-axis here, the point is on 3, and on the y-axis it is negative 3. So the coordinates is 3, negative 3. That is that for B. Then we go to C. For C, translate the point M by the vector negative 3, 5. Negative 3 means we are moving to the left, and 5 means we are moving up by 3 and 5 units respectively. So negative 3, 1, 2, 3, and 5, we move up 1, 2, 3, 4, 5. So this is the point M after translation. So the coordinates of M prime prime is, we read it on the x-axis, that's negative 4, and this is 6. So we have it as negative 4 comma 6. And that is all for problem 4. For your information, do you know that it is possible for you to get the coordinates of the vertices of the object? Then for each coordinate, you are going to have a column vector. Then you now add this translation vector to each of the coordinates. You are going to have the coordinate for the image. That is going to be left for you as an option to verify and use. It is allowed. The x component here is negative 4. So negative 4 plus 4 is 0. You have the 0 here. Then also this is 4. That is the y component. Y component here is negative 4. Negative 4 plus 4 is 0. So you can see now it is 0, 0, and it is at the origin. That is why this vertex is translated to the origin here. The same thing when we translate m by the column vector negative 3, 5. The x component of point M is negative 1. And negative 1 plus negative 3 gives negative 4. Can you see that? And the y component is positive 1. Positive 1 plus 5 gives what? 6. So this is another way of getting the vertices of the image for translation. And this is the highest we are taking in this tutorial. I hope you enjoyed it. Please like and share this video. Remember to check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on transformations. Don't forget to subscribe to our YouTube channel. Until we come your way again, goodbye.